Okay, so let's first draw a diagram representing the situation of the given problem statement. Let me bring the diagram which I have already drawn. So here is the diagram which represents this situation. So if we look at this right side, we have this plastic material with the length 40 centimeter and 15 centimeter. And I have already shown that a square is being cut out from each of the corners. The length of the square is x centimeter, which I have represented over here. So using this blocks, when we cut off the square portions from each of the four corners and then fold it, we are going to get a box like this. And the dimensions of the box will be, since we cut out the square of length x centimeter from each sides, the length of the box will be 40 minus 2x, and similarly the width of the box will be 15 minus 2x, and the height of the box will be x centimeter. So now we can find the volume of this box. Volume is basically the length times width times height. So I'm going to plug in the length as 40 minus 2x times width is 15 minus 2x, and height is x. This basically represents the volume function. So we are going to find the maximum volume using the applications of calculus. Uh, so first let's distribute and write down without these factors. So I'm going to multiply these two factors and then multiply with x. So when I do that, 40 times 15 is 600. Then 40 times negative 2x is negative 80x. Then I multiply negative 2x with 15, I get negative 30x. Then I multiply negative 2x times negative 2x is plus 4x squared. I then have to multiply with x. So this can be simplified. Negative 80x minus 30x is 110x. So I write the volume function as, I put the 4x squared first, then minus 110x plus 600 multiplied by x. So I'll be getting volume equal to 4x cubed minus of 110x squared plus 600x. So this basically represents the volume function. We are going to find the uh, value of x such that the volume is maximum. So for that we need to find out the critical points of this function. Remember that critical point is we find derivative of the volume and set it equal to 0. So let's do that. Let's find the derivative of this volume function. I'm going to differentiate both sides with respect to x. So when I do that, I get dv by dx equals derivative of 4x cube is 12x squared, and derivative of negative 110x squared is 220x, and derivative of 600x is 600. Remember that you have to use the power rule of differentiation to differentiate this volume function. So now let's set this equal to 0 so that we get the critical numbers or the critical point of the volume function. So let me set the dv by dx equals 0, and when I do that I'll be getting 0 here. This is equal to 12x squared minus 220x plus 600. I see that I can divide all the terms by 4. So therefore I'm going to write down this as 0 equals 3x squared minus of 55x plus 150. So this is basically a quadratic equation which can be solved for x. You can use the quadratic formula, and when you solve this using the quadratic formula, you get two values for x. That is, one of the value is x equals 10 by 3 or x equals 15. So basically these two values are the critical numbers of the volume function. We know how to determine that if this critical numbers is giving a maximum volume or minimum volume. So for that we need to do the second derivative. So let's find the second derivative of the volume function. I'm going to find the second derivative over here, that is d2v by dx2 equals, I have to differentiate this 12x squared. When I differentiate the 12x squared, I get 24x, and then minus 220x, differentiate this, you get minus 220. Now we have to use these critical numbers, plug it into the second derivative, and find that if it is coming up as positive or negative. So let's first plug in 10 by 3. So I'm going to plug in d2v by dx squared into this when x equal to 10 by 3. So therefore this is equal to 24 times of 10 by 3 minus 220. So this is equal to 240 divided by 3 minus of 220. So this is basically equal to 240 by 3 is 80 minus of 220. This is basically less than 0. We don't need to find the exact value. 80 minus 220 is definitely less than 0. It's a negative number. So all that we need to identify is whether it is coming up as positive or negative. So we've just determined that the second derivative is coming negative. Therefore, this is a point of maximum. So point of maximum. Now let's also find out if this point x equal to 15 is giving a maximum or minimum value. So I'm going to plug in x equal to 15 into this point. It is x equal to 15, and when I do that, I plug it into this second derivative. So 24 times of 15 minus of 220. So this is equivalent to 360 minus of 220. 360 minus 220. This is basically greater than 0. We don't need to find the exact value once again. So when the second derivative is greater than 0, that is, it is positive, it's a point of minimum. So we can ignore this point. We don't need this. We need only when the volume is maximum, which means x equal to 10 by 3 is the critical number where the volume is maximum. So we can write down this over here when x equal to 10 by 3 centimeter. This is approximately equivalent to 3.33 centimeter. The volume is maximum. So we can find the area of the square that we get. We are going to cut. So this is the x and x. So when x equal to 10 by 3, area of the square is going to be x times x, which is x squared. So this is equivalent to 10 by 3 quantity square, which is equivalent to 100 by 9, and this is approximately 11.11 centimeters square. So this is the area of the square which has to be cut so that when we make a box, the volume of the box is going to be maximum.